Service friends, I am Orpheus Praxis, a researcher of the limits of formal systems and their applicability to reality, and welcome to my channel. May this listening bring you clarity and peace.
Welcome to the deep dive.
Okay.
Today we're going right to the edge, the very edge of reality. A place where our physics, our best understanding, kind of hits a wall.
Right.
Think about the absolute smallest bits of time and space possible. Planck length, Planck time.
Incredibly small scales.
Exactly. And that's where our big theories, like general relativity, quantum mechanics, well, they start to struggle. They predict weird stuff like singularities.
Yeah, points where the physics just seems to break down, like inside a black hole, maybe the Big Bang.
But what if there's another way to look at it?
Precisely. We're diving into this really interesting paper by Boris Batnin and Andrei Price. They call it the Fractal Bindu Spherical 3D Reality Model, or FBS3R for short.
FBS3R. Got it. So our mission today is to unpack how this model might give us a different, maybe more consistent view of the universe way down at that fundamental level.
And tackle those problems head on.
Okay, let's dig in. You mentioned these tiny scales. Planck length. It's like 10 to the minus 35 meters. Incredibly small.
Vanishingly small. And Planck time is even faster, 10 to the minus 44 seconds.
So why do our standard models have such trouble there? Why these singularities?
Well, fundamentally, standard models often predict that space-time itself could shrink down to zero size or infinite density. Mathematically, that's problematic. Division by zero, essentially.
The maths breaks.
Yeah. The FBS3R model proposes something different. It sees the universe not as just empty space, but as a bounded 3D space, a manifold, with this deep fractal structure.
Fractal, like patterns repeating within patterns.
Exactly. Think Mandelbrot set, but for the fabric of reality itself. It's designed to be energetically self-sufficient, stable right from the start.
Okay, a fractal universe. That sounds pretty wild. How does that repeating structure actually work down there to stop everything collapsing?
So the model imagines these nested spherical levels, almost like Russian dolls, but getting smaller, following a specific rule involving the Planck length and, interestingly, the golden ratio.
The golden ratio.
Yeah, but the crucial part is, as time approaches that Planck time limit, the smallest possible geometric scale, according to the model, is always the Planck length.
So it has a built-in floor. It can't go smaller than Planck length.
Exactly. It never collapses to zero. That mathematical structure just prevents it. No division by zero, no singularity based on size.
Okay, that's huge for avoiding those spatial singularities. But what about the fabric itself? Space-time, the metric. Doesn't that still break down?
Good question. Instead of just tearing or going flat, the metric approaches what they call a quantum regularized form.
Quantum regularized, meaning?
It means that tiny quantum fluctuations, sort of inherent jitters in spacetime, actually stabilize the geometry. Think of them like a kind of scaffolding at the Planck scale.
So quantum effects prevent the classical breakdown.
Precisely. They stop the classical evolution right at that limit, so again, no singularity. The geometry stays stable.
It's pretty elegant how these pieces fit. But, okay, another big mystery. Information. What happens to it? Does it get lost in black holes or the Big Bang? Some theories suggest it might.
Right, the information loss paradox. This model handles that too. It uses a version of the Wheeler-DeWitt equation that's a key equation in quantum cosmology, but adapted for this fractal context.
Okay.
And in the Planck limit, the universe's wave function, its quantum description, it normalizes properly. It essentially means probability adds up to 1, which means all the quantum information is preserved. Nothing gets fundamentally lost. It's all accounted for within the wave function.
Wow, okay. No lost information. That's another big problem potentially solved. Now, what about vacuum energy? The ultraviolet catastrophe problem where the energy of empty space seems to blow up to infinity.
Yes. Another classic headache. The model uses a special mathematical tool here, a fractal zeta function.
A fractal what function?
Zeta function. Think of it as a way to handle summing up infinite contributions. Standard physics adds up all possible energy fluctuations, even infinitely small ones, and gets infinity.
Right.
This fractal zeta function takes the fractal structure into account. It acts like a mathematical regulator, making that infinite sum converge to a finite number for the vacuum energy density.
So it tames the infinity because of the fractal nature.
Basically, yes. It avoids the catastrophe by reflecting the underlying fractal geometry.
Okay, let's pull this together. If this model holds, then as we approach the Planck scale, we get a reality with no singularities. Information is fully preserved, vacuum energy is finite, and fundamental symmetries like energy conservation via the Nevers theorem still hold.
Exactly. It all hangs together. The philosophical takeaway is pretty profound, isn't it?
How so?
Well, the Planck limit isn't some chaotic breakdown point or a magical beginning from nothing. It's more like a smooth, stable transition into this quantum fractal state.
So the universe doesn't need an external start button.
It suggests reality might just be inherently self-consistent, dynamically stable, all the way down. No external origin required, perhaps.
This deep dive really does paint a different picture. A universe that puts itself together, even at the absolute extremes, through this intricate, repeating fractal design.
Yeah, it suggests the kind of inherent self-organization and stability, right down to the very bottom. So maybe think about this. How does viewing the universe as fundamentally self-organizing and stable change how you think about reality itself? What does it mean for something to simply exist?
See you in the next one. And until then, keep thinking deeply. Subscribe to stay with us on the path. I'm Orpheus Praxis, wishing you clarity. Namaste.